The first question in our review packet is going to force us to use a couple different properties, some about parallelograms and some about isosceles triangles, to be able to figure out what angle AFD is. So AFD is up there, and the only information they give us is that angle R is 124 degrees. Since they tell us that Fred is a parallelogram, we know that angle FDE is also 124. Now, piece of information that they gave us up top was AF is congruent to DF, making our isosceles triangle. If we do supplementary angles, 124 and angle FDA have to add to 180, so when we subtract, we end up getting 56. Because it is an isosceles triangle, we have our congruent base angles. The next piece, we can take those two angles, since all triangles add to 180, we can do 56 and 56 to get 112. 180 minus 112 will give us what x is, and in this case it is 68 degrees. In the second one, parallelogram QRST has all these diagonals and all these points and other fun stuff. So angle S is 60 degrees, angle SRT is 83 degrees, and TWU is 35. What's the measure of angle WVQ? A couple different ways to go about this. The way I chose to go about it was that angle S and all of angle R have to add to 180 because consecutive angles are supplementary. So 60 and 83 gives you 143. Subtract that from 180, and you're going to get 37 degrees. So that's what goes at the other piece of R. Vertical angles is going to allow us to bring the 35 down. Now you can either get the remaining angle of the triangle at V, or you can do your exterior angle rule, which says the two non-adjacent insides added together give you the exterior, and in this case that gives you 72 degrees. The third one, which information is not enough? And that's the key word, which is not enough to prove it's a parallelogram. Choice A, AB is congruent to CD and AB is parallel to CD. That says one set of sides congruent and parallel. That does work. That is sufficient. All right. Choice B, AB congruent to CD, BC congruent to DA. That's opposite sides congruent. We know that one is a property that works. AB is congruent to CD, and BC is congruent to AD. So now if we look at that one, AB is congruent to CD, and BC is parallel to AD. So if we look at that, this has one set of sides to be congruent and a different set of sides to be parallel. Well, that doesn't seem like one of our properties, but we'll hold on to it for a second. And then choice D says AB is parallel to DC and BC is parallel to AD. That's opposite sides parallel. We know that's the definition of a parallelogram. So therefore, we're left with choice C as the one that is not enough to prove it is a parallelogram. The fourth one, which set of statements would describe a parallelogram that can always be classified as a rhombus? So this is the key. You already know it's a parallelogram. You are now trying to identify which pieces create a rhombus. So choice one, diagonals are perpendicular bisectors of each other. Well, we know the diagonals bisect each other already from the parallelogram piece, and then perpendicular is a factor or is a property of rhombus. So that one does work. Diagonals bisect the angles from which they are drawn. That one is a parallelogram property. Diagonals form four congruent isosceles right triangles. Well, they do form four congruent right triangles, but if it's going to be isosceles, that's going to turn our rhombus into a square. But here's where you have to be very careful. A square is also a rhombus. So therefore, four congruent isosceles right triangles could make it a square, which technically makes it a rhombus. So that's where you have to be very careful and don't get tricked, because that property, although very, very specific to a square, since a square is a rhombus, it would also be able to classify it as a rhombus. So therefore, it is going to be choice D, which is all 1, 2, and 3. In 5, quadrilateral blue, they give you BE is congruent to UL. Which information would be sufficient to prove it is a parallelogram? Well, if you look at choice D and choice E, those are giving you two sides that are next to each other. Those are not going to help us. Now we're left with BL parallel to EU or LU parallel to BE. Well, this one goes back to the same thing as number 3 from the front page, is that if you do BL parallel to EU, that gives you your one set of sides congruent and one set of sides parallel. That does not give us a parallelogram. What we need is we need to look at choice 2 or choice B, where we get LU parallel to BE. That gives you your one set of sides both congruent and parallel, and that's kind of our hidden parallelogram property. An ABCD is a parallelogram. What would make it a rhombus? Well, ABCD, okay. We're going to draw our diagonals in here just in case we need them. Choice A says angle ABC is congruent to angle CDA. Well, that's just opposite angles are congruent. That's a parallelogram property. Doesn't help us prove it's a rhombus. Choice B, AC is congruent to BD. That's a rectangle property. Doesn't help us prove that it is a rhombus. AC perpendicular to BD. Well, that says our diagonals are perpendicular, so seems like our answer is it. And then AB is perpendicular to CD. Well, that's physically impossible. So that one is out. And that leaves us with choice C. Our diagonals are perpendicular. 7. The measures of two consecutive angles of a parallelogram are in a ratio of 3 to 7. Find the acute angle. Well, we're going to draw a parallelogram. And then anytime you're dealing with ratios, you're basically going to take those numbers and put an X after them. In this case, since they are consecutive, I'll put them next to each other, and we know in a parallelogram, consecutive angles add to 180. So 3x plus 7x equals 180. Adds together to give us 10x. Divide both sides by 10, and x is 18. Now the directions don't ask us to find x, they ask us to find the acute angle. So they want the smaller of the two angles, which will be our 3x, and then 3 times 18 gives us 54 degrees. 8. Which reason could be used to prove a parallelogram is a rhombus? So you're looking for properties that a rhombus has that a parallelogram does not. Diagonals are congruent is a rectangle property. Opposite sides are parallel is a parallelogram property. So yes, a rhombus has that property, but since a parallelogram also does, it's not specific enough to tell us that we have a rhombus. Diagonals are perpendicular. That is a rhombus property, so we'll hold on to it for a second. And then opposite angles congruent, that's another parallelogram property that a rhombus will have, but is not specific enough to get us to a rhombus. So the only one that a rhombus has that a parallelogram does not is choice C. 9. So they give you a parallelogram and two consecutive angles. So just like we did before, consecutive angles are supplementary, so we add them up to 180. In this case, they just want us to find x. When we combine like terms, 2x and 5x is 7x, negative 10 and positive 15 is 5, and then equals 180. Subtract our 5 from both sides, we get 7x equals 175. Divide by 7, and x is 25. 10. They give you a diagram of a rhombus, 2 consecutive sides. Really, it doesn't matter in a rhombus what sides they give you. All the sides are congruent. So, subtract 1 on both sides. We get 2x equals 3x minus 9. Subtract our 3x. We get negative x equals negative 9. Divide by negative 1. And x gives you 9, which in this case is exactly what they were asking for again. 11. In rectangle DATE, DT and AE intersect at S. So let's draw ourselves rectangle date. And then our diagonals are going to intersect at S. They tell us AE, so the entire distance from A to E is 40. They tell us ST is x plus 5. Find the value of x. So there are 2 properties that apply here. In a rectangle, the diagonals are congruent, so the entire length of AE is equal to the entire length of DT. And then, from a parallelogram carryover property, the diagonals bisect each other. Tells us that ST, where x plus 5 is going to equal ds, okay, which is blank for now. So, if we're going to solve this, we need 2 x plus 5s to equal the entire length AE, which is 40. Now, in this problem, we're searching for x. We distribute 2x plus 10 equals 40. Subtract 10 on both sides. 2x equals 30. Divide by 2, and x is 15. 12. Find the lengths of the sides of a rhombus whose diagonals measure 12 and 16. So if we draw a rhombus, looks like that. Then we have our diagonals. The key to this problem is we know the diagonals in a rhombus are perpendicular. We're searching for one of the sides. It does not matter which side we find, they're all the same. But then the diagonals also bisect each other. So if the entire length of the longer diagonal is 16, that gives us 8 and 8. And then the shorter diagonal is 12, so 6 and 6. What we have created is a right triangle with 2 sides, and one of them's missing. So we're going to do Pythagorean theorem. The side of your triangle, or excuse me, the side of your rhombus is always C. 6 squared plus 8 squared equals C squared. 6 squared is 36, 8 squared is 64. Add them together, you get 100. Square root both sides, and you get that the side of your rhombus is 10. A quadrilateral with exactly one pair of parallel sides. Well, once you hit parallelogram, you get 2 sets. The only one before that with 1 set is going to be a trapezoid. Which property is not common to all parallelograms? Meaning, it has to be, they're looking for a property that is more specific. Maybe it belongs to a rectangle, maybe it belongs to a rhombus. If it's common to all parallelograms, that means a parallelogram itself has to have it. So if we look at our choices here, opposite sides parallel, that is a parallelogram property. Opposite angles congruent, also a parallelogram property. So we found first 2 are common to all of them. Consecutive angles are supplementary. That also belongs to a parallelogram. And then the last one is diagonals are congruent. Well, that doesn't start until you hit the rectangle. So the rectangle properties are obviously not common to all of them because a regular parallelogram does not have diagonals congruent. In quadrilateral ABCD, if AB is congruent to DC and AD is congruent to BC, then diagonals AC and BD must be what? Well, if we label everything that they gave us, that's what we end up with. We end up with opposite sides congruent. All opposite sides congruent tells us is that we have a parallelogram. So the only thing that we can pick from here about our diagonals, we are only allowed to pick from the properties of parallelograms. Well, be parallel is impossible. Diagonals can't be parallel. Be perpendicular, that starts at a rhombus. Be congruent, that starts at a rectangle. So what are we left with? The only one that a parallelogram has and all of the parallelograms have are that the diagonals bisect each other. So 16, there's a bunch of different ways to do this problem. I think the easiest way, and we're looking to explain why angle NLO is 40 degrees. I would say angle O is 118 degrees because opposite angles in a parallelogram are congruent. All triangles add to 180 degrees. 118 plus 22 gives you 140, and then 180 minus 140 gives you 40 degrees, which is left for angle NLO. So you don't have to write a novel here, but you do have to be very specific, referencing the opposite angles are congruent, and then all triangles add to 180 degrees. The other way that I know some people will probably go about this is consecutive angles are supplementary, and they'll end up getting 40 down there. Then they'll say since opposite sides are parallel, that alternate interior gets you to 40 degrees. Now, if you want to do what I have in red, that's fine. Just please make sure you're very specific throughout the process. All right, the first proof. This is probably one of the easier versions of this proof. So they're telling you it's a parallelogram, and they want you to get diagonals, they want you to get triangle AED is congruent to triangle CEB. So if we make our chart over here on the side, get rid of my little box here. The only thing that they give us in the beginning is that ABCD is a parallelogram. Now, there are many different ways to do this problem. You do not have to do it the way that I did. I'm actually going to do this proof a little bit differently than the one I'm posting on the with the answer key, just to show another example of how you can do this. So for me, I'm going to go step 2. AD is congruent to BC because opposite sides of a parallelogram are congruent. So that gives me one side. Next, I'm going to say AC and BD bisect each other. Now, why is that true? Because the diagonals of a parallelogram bisect each other. From there, I can get AE is congruent to EC, and then I can get BE congruent to DE. So that's what I'm going to use in step 4. AE is congruent to CE, and BE is congruent to DE. Now we want to establish what a bisector is. A bisector divides a segment into two congruent segments. Now, if we look at what we have in each of our triangles, we have side, 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 and side, 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 which is one of our patterns. So triangle AED is congruent to triangle CEB. See, make that a little bit cleaner. CEB, side, side, side. Now there is a way to do this by side angle side if you were to use the vertical angles, or angle angle side, or angle side angle if you chose to then talk about the alternate interior angles that could exist as well. Okay, so definitely options here. It's kind of up to you which method you would like to attack. The last question is describe a single rigid motion that would map the triangles onto each other. That would be a rotation 180 degrees around E. And yes, you need all that information. The shorthand way to do it, rotation centered at E, 180 degrees. Okay, so that's the first proof. Again, multiple ways to do it. I have a different way with side angle side and the vertical angles posted with the answer key on Google Classroom. The last proof, a little bit more challenging. I haven't found as many ways to go about this one, although there are more than what is just going to be on the board here. So I'll start with my givens. If we look at what we're trying to prove, we're trying to prove AE is congruent to FC, which makes me think that I'm going to try to find a way to establish my little triangles on either side to be congruent. So I have quadrilateral ABCD with AB congruent to CD, AB parallel to CD, and then BF and DE perpendicular to AC. Okay. So that was all my given information. Now here's kind of the key to this problem is recognizing they told us AB and DC were congruent as well as parallel. When you have the same set of sides congruent and parallel, you can say that you have a parallelogram. And this step is going to make it a lot easier. So if we state that this is a parallelogram, because all the given information really is in the other two triangles, not the ones we're looking for. So the reason is a quadrilateral with one set of sides congruent and parallel. So once we say that, now we have the ability to use any property about parallelograms that we know. Well, I'm going to go ahead and grab then that AD is congruent to BC. Now I'm starting to grab information that's in the triangles that we need. So opposite sides in a parallelogram are congruent. I'm also going to talk about the same two sides being parallel, because there's definitely something else I can get out of that information. So just like above, except now opposite sides in a parallelogram are parallel. What did I use that for? I used that for the fact that I want angle 1 and angle 2 to be congruent. They are alternate interior angles. Angle 1 congruent to angle 2. Parallel lines form congruent alternate interior angles. So I still have a given I haven't used. I have the perpendicular given. Well, I get each of those perpendiculars at BF and at DE get me two right angles, but I just want to talk about the ones that I'm going to use in my little triangles. So next I want to say angle 3 and angle 4 are right angles. And the reason that that's true is because perpendicular lines form right angles. And then the continuation of that is angle 3 is congruent to angle 4. All right angles are congruent. So now if we just go back up and check our picture, what do we have? We have angle, angle, side, and we have angle, angle, side. So now our triangles are going to be congruent. Didn't mean to skip a page. Scroll back down here. So step 8 is going to be triangle ADE is congruent to triangle CBF, angle, angle, side. And then we can grab our last piece, our proof statement, which is AE is congruent to CF, CPCT, C. And now we've got ourselves a completed proof. There was a way to do it if you talked about the top and bottom triangles to be congruent. You could do it that way as well, and then find a way to do some subtraction. I didn't find that to be the easiest way, which is why I chose not to do it. But there's absolutely another way to do it with subtraction as well. So I hope this helps. And any questions, make sure you bring them to class tomorrow.